Good morning, everyone. Today I will be presenting on the topic deterministic pushdown automata and deterministic context-free languages, which is an important topic in theory of computation. On this topic, we will cover starting from the very basics of automata and stacks and all the way to properties and real-world applications of this automata. Before we dive in, let's understand two basic building blocks. First is an automaton and second is stack. An automaton. It is simply a machine that reads input and decides to accept or reject it. Secondly, a stack. Simply think of it like a pile of plates. You can only add or remove from the top. This is called reform, last in, first out. Push means add to the top, pop means removing from the top. What is a PDA? A push-down automaton or PDA is a finite automaton with a stack attached to it. Think of it like a security guard which reads your ID. The ID is the input, okay? Takes notes on a notepad, which is a stack, okay? And decides if you're allowed in. Formally, it is defined as a 7-tuple with states, alphabets, a stack, and transition function. Now let's talk about a deterministic PDA or DPDA. It is a PDA where at every step there is exactly one possible action. No guessing, no choices. Here the key rule is for any combination of state, input symbol and stack top there must be at most one transition. This is what makes it deterministic. Let's look at a simple example for DPDA. The language A raised to n b raised to n means strings with equal number of A's followed by equal number of B's. Just like AB or AABB, AAABB, BBB, like 3 and 3 B's, okay? So here the DPDA works like for every A read, push an A onto the stack. For every B read, pop an A. If the stack is empty at the end, we accept it. Uh, just look at this trace table I have shown here. That is exactly how AABB is processed. As you can see, when it reads, it pushes a to the z, like z is the initialized stack, okay, and then we reads the a, again it pushes a, and then we reads b, it pops out the a, then it becomes az. That's how exactly it works. It's a simple example for this DPDA. Now let's talk about context-free language. A context-free language is any language that can be generated by a context-free grammar and recognized by a PDA. They sit in the middle of the language hierarchy. It is more powerful than any regular language, but is not as powerful as full Turing machines. For example, it includes balanced parentheses and arithmetic expressions. Deterministic context-free languages. A deterministic context-free language is a stricter subset. It can only be recognized by DPDA, deterministic push-down automaton. As shown in the diagram, all DCFLs are CFLs, but not all CFLs are DCFLs. Okay, it is an important point. Okay, for example, palindromes cannot be recognized by a DPDA because the machine does not know when it has reached the middle of the string, okay, because it is a palindromes. Let's have a quick comparison between DPDA and PDA. The key difference between PDA and DPDA is PDA can have multiple choices at each step, while DPDA has exactly one. This makes PDA more powerful but also less practical. Also, DCFLs are used in real compilers. Palindromes requires a non-deterministic PDA. It does not palindromes cannot be worked in, cannot be an example for cannot be used in DCFLs. Deterministic context-free languages have have important mathematical properties. They are closed under complementation, but they are not closed under union or intersection. In the real world, deterministic push-down automatons are used in compilers to pass code, or also in XML validators to check nested tags, or also used in calculators to evaluate expressions. So in short, a stack has a structure of uniform, lasting first-step structure. A PDA adds a stack to a finite automaton. A DPDA restricts it into a one transition first step. Also, context-free languages are recognized by PDAs, and deterministic context-free languages are recognized by deterministic PDAs. PDAs, I mean push-down automatons. Okay. So the key hierarchy is more like regular language is a subset of DCFL. DCFL is a subset of CFL. CFL is a subset of all languages. That's all about it. Thank you.